Good morning, students. Here is our review for Chapter 8. So basically what the review is we're just going to go through this test B and follow along. If you have any questions, let me know. So here we have similar polygons. It tells us, so it's given that they're similar, so we're going to find the value of x. So we just make sure we line up the right sides with the right sides. So 12 goes with 15, x goes with 25, 24 goes with this. So we're going to use the 12 over 15 equals x over 25. Do my butterfly method, so 15 times x equals 12 times 25. 12 times 25 is, where's my calculator? 12 times 25 is 300. Divide both sides by 15, and I get x equals 20. All right, so x equals 20. All right, number 2. So these are flipped over, right? Because this is here. And this is the hypotenuse. This is the hypotenuse, this is the hypotenuse. So when we're figuring out this side length goes with this side length. So I have x plus 1 over x plus 5 equals the shortest length and the shortest length, 12 over 15. There's my equation. And now I do my butterfly thing where I go across. So I go 15 times x and 15 times 1, right? Because it's 15 times x plus 1 equals 12 times x plus 5. So I get 15x plus 15, because I distribute, equals 12x plus 60. Let's go ahead and subtract 12x. So I get 3x plus 15 equals 60. Boy, I should have done this on a different piece of paper. Minus 15, we get 3x equals 45. Divide by 3, and I get x equals 15. Okay, got a little bit crowded there, but we'll do this next one on a separate sheet of paper. So what do I have when I'm doing comparing these? Well, we know that they're similar triangles. So what I get is this length to this length is the same as this length to this length. So 3, negative 3 plus 2x is 227. What 8 is 224? And just to make this easier, I noticed that 8 is and 24, those are common. I could divide them both by 8. So I'm going to simplify this. I'm going to simplify it to 1 over 3. That makes it way easier, right? So I got 27 equals negative 9 plus 6x, right? Because 3 times negative 3 is negative 9. 3 times 2x is 6x. Add 9, and I get 36 equals 6x. Divide by 6, and I get x equals 6. All right, moving on. Find the scale factor. Well, first I have to orient these so that I know which side is with which side. And when they give us all 3 sides, it's easy actually to know which side is with which, because I can go, smallest side and smallest side. So for number 4, I have 20 is to 24, and then mediumest side would be 25 and 30, as 25 is to 30, and the largest side, 35 is to 42. Now they're asking us to list the pair of congruent. We're not going to do all that. We're just going to go ahead and just find the scale factor. So the scale factor, we need to simplify all these. What can go into both of these? 4 can go into both of these. So 20 divided by 4 is 5. 24 divided by 4 is 6. Both these are divisible by 5. 25 divided by 5 is 5. 30 divided by 5 is 6. Both these are divisible by 7. 35 divided by 7 is 5. 42 divided by 7 is 6. So there it is. My scale factor is 5, 6, and I found that they do, in fact, have a common ratio. Okay? Number 5, it looks as though it's oriented the right way, but we'll still do the same thing. We'll go smallest. Oh, we don't know that side length. So we'll go smallest side length. We'll assume that this is, these are the same. So that means these two would be the same. So we have 14 over 35. Second smallest, 16 over 40. Next smallest, 18 over 45. And then we have another 14 over 35. So we don't need it because it's already here. So we'll simplify and see if we have a common scale factor. These are both divisible by 7. So I get 2/5. These are divisible by 8. So I get 2/5. These are both divisible by 9. So 18 divided by 9 is 2. 45 divided by 9 is 5. So there is our scale factor for number 5. Scale factor equals 2/5. And for number 4, our scale factor equals 5, 6. All right, very good. Moving on, number 6. Pittsburgh, Pennsylvania State College, 9.5 inches apart on the map. 9.8 inches apart on the map, and has a scale factor of 1.1. So 9.8, and the scale factor is 1.1. 1.1 inches equals 15 miles. 1.1 equals 15 miles. How far apart is it in real life? So we have the map and the scale factor, the real life and the real life. That's how we set that one up. So we do our butterfly thing like that. So we get 1.1x equals 9.8 times 15, which is 147. And then we divide by 1.1. And we get x equals 133.64. So 133 miles, 133 and 64 100ths miles. All right, number 7. A model house is 12 centimeters long. Okay, it's built with a scale factor of 3 centimeters equals 7 feet. So it's 12 centimeters long on the paper in the model. 3 centimeters is equal to 7 feet. How long is the house in real life? Here's your real life numbers. Here's your centimeters. So we have 3x equals 84. 12 times 7 is 84. Divide both sides by 3, and I get x equals 28. So the real house is 28 feet. All right. Let's check these out. Show that these are similar. How do we know? Write the similarity statement. So if this is 57, this is 57. Now, we've talked about this, but anytime you have two lines that cross, this is equal to this, and this is equal to this, if they just cross. So that would mean that this is equal to this. So it looks like we have an angle that's the same and another angle that's the same. So this is angle similarity theorem. Okay? Boom, done. There's your similarity statement. And let's check out this. Well, here's two lines that are crossing. So boom, we already know this angle is equal to this, but we don't have any other angles. But we do know that this side is equal to this side. This angle is equal to this angle, and this side is equal to this side. Oh, side, angle, side. Look at that. Side, angle, side, similarity theorem. Now, when these are asked on the test, you have to label these to show me how you got to it. Okay? These ones I encourage you to do in pencil because when you draw, we have two separate problems for this. So ED is 8. DC is 10. EC is 12. AB is 12. BC is 15. And AC, this whole one, is 21. This whole length right here. So prove that they're similar. Well, to prove that they're similar, I just have to take the ratios. So take my smallest side length. So 8. My smallest one on this is 12. So 8 to 12 should equal, my next is 10 to 15, and my next is 12 to 21. So are they same scale factor? Those can both be divided by 4, so I get 2/3. These can both be divided by 5, so I get 2/3. These can both be divided by 3, so I get 7/4. So no, in fact, number 10, I cannot prove similarity. Nope, sorry. Okay, let's check out number 11. So I'm going to erase all these numbers so I can label it for number 11. And you see, that's why I couldn't get it, because I had 2/3, 2/3, 4/7. 4/7 is not the same. All right. ED is 7. DC is 9. AB is 10.5. BC is 13.5. BAC plus BCA is 105. Well, that doesn't tell us anything. I mean, it tells us that this plus this is 105, but I don't know what either of these are independently. So with those side lengths, I don't know if this EC compares to AC, so nope. Sorry. Can't figure it out. All right. Let's keep going. Here we got some drawings. So consider these vertices. This is supposed to be a triangle. Is after dilation is this. So here we have it. The blue is before dilation, A, B, C, and the red is after dilation, A prime, B prime, C prime. What's the scale factor? Well, I wrote out here's A, B, C, here's A prime, B prime, C prime. And so 0, 0, that doesn't give me anything to go with, but I have a 4 and a 10. So 10 divided by 4 is 2.5. So we're going to double check with our next one. And if we get the same scale factor, then sure enough. So I have a 15 and a 6. So 15 divided by 6. Look at that. So our scale factor is 2.5. There you go. All right. The next one, number 13. Number 13, we have -2.5, 1.8, and 7.5. So that's A, B, C. And it says we have a scale factor of 3.5, right? 3.5 is the same as 3.5. So if we have that scale factor, what are the coordinates of our next one? Well, let's get, where's my red pen? We'll do -2 times 3.5. It didn't show up as negative, but that's 7. It's -7. So I have A prime is -7, and then 5 times 3.5 is 17.5. B prime, 1 times 3.5 is 3.5. 8 times 3.5 is 28. And then C prime, 7 times 3.5 And then 5 times 3.5. So there is your new coordinates. I've got -7, 17.5, 3.5, 28, and then 24.5, 17.5. All right, 14. Describe the transformations that happen. So here's 14 right here. I've got our original figure is in blue, and then our transformed figure is here in red. So here's our originals, and here's our transforms. What's the scale factor? Well, how did I get from -6 to 2? I divided by 3. 6 to 2. Is it supposed to be negatives? That's a -6. Negative. So that's divided by 3. How about this one? 6 to -6, -2. That's divided by 3. 3 to 1. That's divided by 3. So our scale factor divided by 3 is times 1/3. Right? Our scale factor is multiplication. So if it's divided by 3, it's just times 1/3. So our scale factor is 1/3. All right. And 15. Let's look at 15. So we have our start right here, and we have our finish right here. So what we're going to do is we're going to do a scale factor, and then we're going to do a translation. So this side length 1, 2. This side length 1, 2, 3, 4. So my scale factor is times 2. So I'm going to have 2, 4. I'm going to have 4, 4. I'm going to have 2, 8. So 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2. And then up to 8. 1, 2, 3, 4, 5, 6, 7, 8. So now I've got the right size. Now I just have to move it. So if we go, let's say this point to this point, we have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and over 1, 2. So it's right 2, x plus 2, y minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Y minus 10. And let's see if that works for each one of them. So x plus 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So there's our translation. So your scale factor and your translation for number 15. All right, number 16, your geometry class goes on a field trip to the zoo. If you have an 18-foot tall tree that casts a 9-foot shadow, how tall is a giraffe that casts a 7-foot shadow? So here you see you got 18, the scale of 18 to 9 equals x over 7. So you got 9x equals 18 times 7, 126. X equals 14. So a giraffe is 14 feet tall. All right, how about this next one? This next one's kind of cool. Hopefully you thought about it for a second. So a 4-foot tall girl, so here's the girl standing at 4 feet tall, stands 6.5 feet from a street lamp. So it's 6.5 feet from a street lamp, and her shadow is 2.5. So how tall is the street lamp? Well, the cool thing is we just created this proportion, right? These are two parallel lines. So the small to the large equals the small to the large, which we don't know. We don't know what the large is. So we have 2.5x equals 4 times 6.5. divided by 2.5. I get x equals 10.4. Just like that. All right. Let's see here now. All right, 18. So now we're using this 3 parallel lines. So these are misplaced. They need to go down a little bit. So this is actually, E is right here, F is right here, and G is right here. So that's where it should be, okay? So if you didn't fix that, these would be terribly difficult. So EF is to FG as BA is to BC. Okay? CB is to BA as EF is to FG. 20. AB is to AC, so AB is to the whole thing as, well, where's D? This is kind of getting messed up. AB is to AC, but where's FD? Well, you know what? We're gonna skip those two. Okay. Last couple ones. Here we go. Now, what's the proportion? Well, we learned that this to this is the same as this to this. So we have 4 to 12 equals x to 18. So 12x equals 72. Divided by 12, x equals 6. And here, you have this whole length. And then, so this length right here would be 20 minus x. So, what do we have compared? Is it this to this? Let's check it out. Hold on a second. Looking at my notes. So, AD is to DB. So, this is to this as this is to this. So, x is to 20 minus x as 14 is to 11. So the work for this, I have 11x equals, what's 14 times 20? $280. 280 minus 14x. So since this is a negative, I'm going to move it over here, plus 14x, plus 14x. So I get 25x equals 280. So I divide it by 25. X equals 11.2. All right, we're going to stop right there and get going with class. So let me know if you have any questions, and that is the review.